All right, so today we're going to be solving equations that uses log properties. So remember that when you solve a logarithmic equation, you do need to consider the domain. All right, so in example A, the first thing I'm going to do, and I'm going to do this nice and slowly, is I'm going to condense the first two logarithms as a product, okay? Then I'm going to multitask here. I'm going to go ahead and expand that and make that x squared minus x minus 6. But then I'm going to divide by the x. So I'm going to take care of this logarithm. So when you take one log divided by another log, that is the quotient. So now I'm going to go from logarithmic form to exponential form. Okay, I'm going to cross multiply and get 4 equals x squared minus x minus 6. Oops, sorry. This was 4x, sorry. Let me fix that real quick. Okay, so that was 4x. Sorry, I needed to multiply both sides by the x. Then that's x squared minus 5x minus 6. So that factors into x minus 6, x plus 1. Now you're going to check this in the original equation. I cannot put the negative 1 here. Okay, and I can't put the negative 1 here. So the negative 1 isn't working. Now let's check the 6. 6 plus 2, that's a positive. 6 minus 3 is a positive, and 6 is a positive. So x equals 6 is my answer. All right, let's look at part B. All right, there's actually a couple different techniques you can use. The one I'm going to do is I'm going to take the natural log to both sides. And what that allows me to do is, do you remember the power property? So I can bring the 2x plus 1 down, but that's going to be times the natural log of 7. Similarly, I'm going to bring the power down, the x plus 2, but make sure you're putting that exponent, since it's a sum, in a parenthesis. All right, so then this is going to be 2x times the natural log of 7 plus the natural log of 7. Keep in mind, natural log 7 is a number, okay? So then I'm going to get x natural log 3 plus 2 natural log 3. So what I want to do now is I want to collect the x terms. So I'm going to subtract x natural log 3, and I'm going to subtract the natural log 7. From here, I'm going to factor out the x. I'm going to go with my calculator here. And then when I divide by 2 natural log 7 minus natural log 3, what I'm going to ask you to do is just punch that into the calculator, and I get 0.09. You don't need to check an exponential equation, okay? You only have to check logarithmic equations. All right, let's try letter B, or excuse me, letter C. So the first thing I'm going to do is I'm going to use the power property to condense. So that'll be log base 9x plus log base 3x cubed equals 4. Then I'm going to multiply, and hopefully you understand that's x. Oops, wait a minute. These are not the same base. I just caught this. Okay, wait. So those are not the same base. So we have a bit of a problem here. All right, so I'm thinking, what could I do here? How could I change this so that it has the same base here? Okay, I really would like that to be a base 3. So I'm going to rewrite it like this. See if you can recognize the change of base. Well, the denominator is 2. So that's like saying 1/2 log base 3 of x plus log base 3 x cubed. So, you know what I might actually do here is if I bring that 3 back down, do you see I can take 1/2 plus 3, which is 3.5 log base 3x. If I divide both sides by 3.5, that's actually 8/7. Then I can do 3 to the 8/7 power is x. I could leave it like that, that's super ugly, or do the decimal. I do a quick check and 3.51 works. All right, example B. It says the world-famous pastry chef Bernie de Rolls removes a completely baked cake from an oven and places it upon a cooling rack in a room whose temperature is kept at a constant 60 degrees Fahrenheit. It is known that the natural log of t minus 60 equals kt plus natural log 40. After 10 minutes, the temperature of the cake is 90 degrees. It says use this to solve for k. So what I'm going to do is I'm going to replace capital T with 60. Oops, sorry. Not 60. Let me try that again. No, it says after 10 minutes the cake is 90 degrees. So that's 10 comma 90 degrees. So I'm going to make capital T 90. The time is 10 plus the natural log of 40. So that's the natural log of 30 is the natural log 10k plus the natural log of 40. Now watch this. This is really, really cool. I'm going to subtract the natural log of 40. But if I condense that, do you see how that is the natural log of 3/4? And then you divide by 10. And this is your k value, okay? And we could, in fact, get a decimal, but I'd rather leave it exact because then that's going to help me get more accurate final answers. So then let's look at letter B. It says use your answer from part A to solve this equation for capital T. Leave your answer as a simplified exponential equation without any horizontal translations. So I'm going to come back to the original equation that's right here, okay? And what I'm doing is I'm going to then plug in that k is 1/10, the natural log of 3/4 times t plus the natural log of 40. All right, so this is where you need to put your thinking hats on, okay? So watch, I'm going to go from logarithmic form to exponential form. So I'm going to take the left side and make it e to the 1/10 natural log of 3/4 t plus the natural log of 40 equals capital T minus 60. All right, so now what I'm going to do is I'm going to rewrite this where I'm going to bring the 1/10 up on top of your natural log. And I'm going to use the product property. And when I bring that power to a power, this is going to be e to the natural log of 3/4. And I'm actually going to pull the 1/10 t out. And then that becomes times 40 equals t minus 60 because e to the ln cancels. And then my e to the ln cancels. And that's going to be 3/4 to the t over 10. I can put the 40 in front because that's a constant. Plus 60 equals t. All right, so this is a bit confusing, okay? So you've got that this is going up to the power, but you can then pull out that you are really multiplying by the t, so you can do the power to a power. So that's how the 1/10 and the t come out again. All right, letter C. The icing that is used for the cake cannot be applied until the cake's temperature reaches 80 degrees Fahrenheit. How much longer must Bernie wait to ice the cake? So this time what we're going to do is we're going to let capital T be 80. We're going to use our condensed formula and just solve this for T. So I subtract 60 from both sides of the equation. I divide by 40. And now what I'm going to do is I'm going to go from exponential form to logarithmic form. Then what you're going to do is you're going to multiply both sides by 10, and then you're going to grab your calculators. And I'm getting 24.094. However, it says how much longer must Bernie wait to ice the cake? Well, Bernie has to wait a total of 24.1 minutes, but do you realize it has, after 10 minutes, it's at 90. So it's a total of 24 minutes from the moment the cake came out. But it's been 10 minutes. So we would say, so it's 14.1 more minutes. All right, there you go.